Hi students, in this video we're going to look at how to draw scatterplots. Alright, so after watching this video you should be able to define the explanatory and the response variables of an experiment, recall which variable we plot on which axis when we're creating a scatterplot, and also create a scatterplot from bivariate numerical data. Right, the biggest things you have to remember. So remembering our definition for bivariate data. So we're collecting two distinctly different pieces of data, or put another way, two different variables. So hence bivariate, two variables. Remembering our types of data, we're going to look at numericals in this case, and also scatterplots rely a lot on plotting points on a Cartesian plane. So we'll have to recall how to use our Cartesian plane to plot points and draw lines and graphs and curves as well. Alright, so scatterplots are used to display bivariate numerical data. So two variables and numbers. They're often used to help us identify whether or not two variables actually relate to each other or not. Now, the two variables that we collect, they both have two important names and two important uses, and that's important when it comes to graphing them on a scatterplot. So first of all is the explanatory variable. This one here. It's also known as the independent variable. That might be how you refer to it in science. And the explanatory variable is the variable that's deliberately changed by the person doing the experiment or the investigation, whatever it is. But that's the thing that's being deliberately changed, or that's the thing that's being analyzed. And the response variable is what in science you'd call it the dependent variable. That's the variable that is going to respond, or that's going to change in response to changes in the explanatory variable. So response variable, it responds, it changes. And we're going to talk about a way that you can tell which variable is which based on how a question's posed or based on what sort of investigation you might be doing. Right, the easiest way to identify the explanatory variable is to think about which variable could affect the other. So which variable could affect the other. So looking at an example, let's identify the explanatory and response variables in the following situation. Right, so we've got the sales of ice cream during the day and the maximum temperature during the day. So those are our two variables. One of them is our explanatory, one of them is our response. Now, the explanatory variable is the one that could affect the other, or the explanatory variable could affect the response variable. So could the sales of ice cream affect the maximum daily temperature? That doesn't really make sense, right? So sales cannot affect the maximum temperature. However, the maximum temperature could affect the sales of ice cream. So that means the maximum temperature is our explanatory variable because it could affect the sales of ice cream, which is our response variable. Now, the explanatory variable is always plotted on the x-axis, and the response variable is always plotted on the y-axis. All right, so let's look at plotting a scatterplot ourselves. So we've got a table that shows the rebound height of a ball when it's dropped from different heights. Now, our first step is to identify our explanatory and our response variables. So remember how we can tell the difference. Which variable should or could affect the other? Now, could the drop height affect the rebound height? Well, yeah, that actually makes a lot of sense. So our drop height is probably our explanatory variable. Our rebound height is our response variable. Thinking about it the other way, could our rebound height affect our drop height? That doesn't make sense because you need to have the drop height first, then you measure the rebound after that. So it's definitely drop height affecting rebound height. Drop height is explanatory, rebound height is response. So drop height is explanatory, rebound height is response. All right, so let's now draw our scatter plot for this data. All right, and we'll just take each point one at a time using the coordinates given here. Now, along our x-axis, we said that the drop height was our explanatory variable. So that will be along here. That's our drop height. That's in meters. And along our y-axis is our response variable, our dependent variable, which is our rebound height, also measured in meters. Right, so our first point is 0.3, which is going to be right here. 0.24, which is going to be right here. There's my first plotted point there. Next one is 0.5 and 0.36. There's 0.536, sorry. That's 36 is just below 34, so 35 will be a little bit below that. So maybe right there. Also, 1.1 and 0.79. So 1.1 will be here. 0.79 will be right below that 0.8 line, so maybe right there. And then 1.8 is up here, 1.25. There's 1.24, so a little bit above that. And that'll be up there. Now, remember, students, when we're doing our graphs, all graphs always need salt. Okay, so our scale is good. All of our data points fit nice and neatly onto our scatter plot. Our axes, they're all evenly spaced. They all go up in 0.2s. Our axes have labels. That's fine too. The last thing we need is a title. So a title could just be something as simple as the effect of the drop height on the rebound height of a ball. That's a pretty standard way to write a title. You can just have effect of the explanatory variable on the response variable. And that's a pretty simple title you can use just for any sort of scatter plot at all, really. And there's our scatter plot. Right, so after watching this video, you should be able to define the explanatory and response variables of an experiment. Recall which variable is graphed on which axis. So explanatory is on the x, explanatory x-axis, and the response variable is on the y-axis. Then finally, you should be able to create a scatter plot from bivariate numerical data.